Hello, welcome one and all. Today we shall see frequency distributions. The statistics is the most important subject and it's applicable to almost each and every field. In statistics, the descriptive statistics is most important, and in descriptive statistics we shall see frequency distributions. So what is frequency distribution? For applying statistical methods, one has to have data. So you have to collect the data, and after collecting the data, the first task for a researcher is to organize and simplify the data. Why? Because to get a general overview of the results. This is the goal of descriptive statistical techniques. And the most simple method of organizing data is to construct frequency distribution. What is it? It is an organized tabulation showing exactly how many individuals are located in each category on the scale of measurement. Frequency distribution presents an organized picture of the entire set of scores. It shows where each individual is located relative to others in the distribution. We construct frequency distribution and we get the table. And what does that table consist? It consists of at least two columns. There may be more than two columns, but at least two columns have to be there. One listing categories on the scale of measurement, better to say it is a variable. And in second column, we write the corresponding frequencies. In the column X, we list all the values right from either lowest to highest or highest to lowest without keeping any. And for the next column, that is the frequency column, we use tallies to determine for each value how often each X value occurs in the data set. These tallies are the frequencies for each X value. And if we add up all these frequencies, we get the total frequencies, that is capital N. We denote it by capital N. Capital N is nothing but sum of all frequencies. And third column can be used if we need to have the column of proportion for each category. And that is nothing but use the formula small p is equal to F divided by N. And the sum of the column P should be equal to 1. We prepare fourth column, and where we can display the percentage of the distribution corresponding to each value of X. The percentage is found by multiplying P by 100, and the sum of the percentage no doubt would be the 100. Regular frequency distribution. When a frequency distribution table lists all of the individual categories, X values, it is called a regular frequency distribution. And what is grouped frequency distribution? Sometimes, however, a set of scores covers a wide range of values. In these situations, a list of all the X values would be quite long, too long to be a simple presentation of the data. To remedy this situation, we prepare grouped frequency distribution. We use grouped frequency distribution. So what is it? In a grouped frequency distribution table, the X column lists group of scores called class intervals rather than individual values. We get classes rather than the separated values. These intervals all have the same width. It is generally 2 or multiple up to 5, 10 or multiple of 5, 10 and so on. Each interval begins with a value that is a multiple of the interval width. The interval width is selected so that the table will have approximately 10 intervals. You may have more intervals, but usually we shall have 10 individuals. Next we see frequency distribution graphs. In a frequency distribution graph, the score categories, x values, be careful, x values means values of variable, and those are listed on the x-axis and the frequencies are listed on the y-axis. When the score categories consist of numerical scores from an interval or ratio scale, the graph should be either a histogram or polygon. So frequency distribution graphs means histogram, we get frequency polygon, we may get further step frequency curve. In a histogram, a bar is centered above each score, that is above class interval, so that the height of the bar corresponds to the frequency and the width extends to the real limits so that adjacent bars touch each other. So looking at the histogram I have plotted for individual data and grouped data. Along x-axis we take the values of x, that is quiz scores number correct, and corresponding frequencies along y-axis. We may get different types of histograms. Next we can construct frequency polygons or simply polygons. In a polygon, a dot is centered above each square so that the height of the dot corresponds to the frequency. The dots are then connected by straight lines. An additional line is drawn at each end to bring the graph back to a zero frequency. So these are the frequency polygons constructed for the data just we had discussed earlier. Next we can have bar graphs. When the score categories, that is the values of x, that is the values of variable, are measurements from a nominal or an ordinal scale, the graph should be a bar graph. It is just like a histogram, except that gaps or spaces are left between adjacent bars. In histograms, there were no gaps, no spaces between adjacent bars. But in bar graph, those spaces or gaps are left between adjacent bars. So if you look at the chart, we see the rectangles on x-axis are erected and there are spaces, gaps between rectangles. We can calculate relative frequency. Many populations are so large that it is impossible to know the exact number of individuals for any specific category. In these situations, population distributions can be shown using relative frequency instead of the absolute number of individuals for each category. We can consider one variable on x-axis, for instance type of fish, and on y-axis we can have relative frequency. Smooth curve. Earlier we had seen histogram, then the next step we had seen the frequency polygon, and in frequency polygon we have connected the top points of each and every rectangle by a straight line. Instead of joining those points by a straight line, if we join those points by a smooth freehand curve, then whatever we get is a smooth curve. Smooth curve emphasizes the fact that the distribution is not showing the exact frequency for each category. So this is the frequency curve. We have a curve taking x values, that is the IQ squares for instance, along x-axis and relative frequencies along y-axis. Frequency distribution graphs. Frequency distribution graphs are useful because they show the entire set of scores. At a glance, you can determine the highest score, the lowest score, and where the scores are centered. The graph also shows whether the scores are clustered together or scattered over a wide range. Next is the shape. A graph shows the shape of the distribution. Distribution is symmetrical in the left side of the graph, roughly a mirror image on the right side. One example of symmetrical distribution is the bell-shaped, that is the normal distribution curve. On the other hand, distributions are skewed when scores pile upon one side of the distribution, leaving a tail of a few extreme values on the other side. So, distributions may be positively or negatively skewed. In a positively skewed distribution, the scores tend to pile upon the left side of the distribution with the tail tapering off to the right. And in a negatively skewed distribution, the scores tend to pile up on the right side and the tail points to the left. Some are the symmetrical distributions, and the two distributions, if you look at the screen, positively skewed, negatively skewed. And I have taken the help from the internet. Thank you.